Did ISRO intentionally hide a terrifying truth from the entire world? A secret that could have permanently altered our understanding of alien life? For years, this mystery remained buried deep within space history. But a top NASA scientist would eventually expose a controversial reality that left many people asking difficult questions. The world remembers India making history by reaching Mars on its very first attempt for just $74 million. It was one of the greatest achievements in modern space exploration. But what many people don't know is that Mangalyaan's most important scientific instrument, the one specifically designed to search for signs of methane on Mars, later became the center of an international scientific controversy. Nearly 140 million miles away lies a frozen desert where humans couldn't survive for even a few minutes. Yet, for 8 long years, India's spacecraft silently orbited this hostile world, collecting valuable information about a planet that may once have looked surprisingly similar to Earth. During its lifetime, Mangalyaan transmitted almost 2 terabytes of data back to Earth. Yet, an unusual question continued to bother some observers. NASA's MAVEN mission arrived at Mars in the same year and contributed to hundreds of scientific studies. Mangalyaan also gathered a massive amount of information, but resulted in far fewer published papers. Why? Was it simply because the missions had different objectives, or was something more interesting hiding beneath the surface? To understand the controversy, we have to go back to where this incredible story began. In the early days of India's space program, there were no giant launch complexes or billion-dollar facilities. Scientists worked from a small church building in Thumba, Kerala. Rocket components were transported on bicycles and bullock carts. At the time, few people could have imagined that this modest program would one day send a spacecraft to another planet. When ISRO announced its Mars mission, many critics doubted it could succeed. Some Western media outlets openly mocked India's ambitions. The mission seemed almost impossible. Unlike major space powers, India did not possess a heavy-lift rocket capable of sending a spacecraft directly to Mars. ISRO's PSLV rocket was reliable, but it lacked the power needed for a direct interplanetary journey. So the engineers came up with an ingenious solution. Instead of heading straight for Mars, Mangalyaan first entered orbit around Earth. Over the next several weeks, the spacecraft fired its engines multiple times, gradually expanding its orbit farther and farther from Earth. Finally, on December 1st, 2013, the last major burn pushed the spacecraft beyond Earth's gravitational grip and sent it racing toward Mars on a journey of nearly 400 million miles. A tiny mistake in navigation could have doomed the entire mission. 10 months later, Mangalyaan approached Mars. Now came the most dangerous moment of the mission. The spacecraft had to fire its engine at exactly the right time and for exactly the right duration. If the burn was too short, the spacecraft would fly past Mars forever. If it was too long, the mission could end in disaster. For several tense minutes, communication disappeared as Mangalyaan moved behind the planet. Mission control could only wait. Then the signal returned. India had become the first nation in human history to successfully reach Mars on its very first attempt. The achievement stunned the world. But behind the celebrations, another story was beginning to unfold. Among Mangalyaan's scientific instruments was the methane sensor for Mars. This instrument carried enormous expectations because methane is one of the most intriguing gases in planetary science. On Earth, methane can be produced by geological activity, but it is also associated with living organisms. Earlier observations, including measurements from NASA's Curiosity rover, had hinted that methane might exist on Mars. If Mangalyaan could confirm those findings from orbit, it would become one of the most important discoveries in the history of planetary exploration. Scientists around the world were eagerly waiting for the results. Then came the controversy. A NASA scientist published an analysis arguing that the instrument's design faced a serious limitation. According to the criticism, the sensor could struggle to separate actual methane signatures from sunlight reflected by Martian dust and surface features. If that criticism was correct, detecting methane accurately would be extremely difficult. The debate quickly spread through the scientific community. Supporters argued that the instrument still had scientific value. Critics claimed its ability to detect methane was far more limited than originally advertised. As the years passed, the methane sensor never delivered the dramatic breakthrough many had hoped for. And just like that, the mission's most heavily promoted experiment faded into the background. But surprisingly, this was not the end of Mangalyaan's scientific success. Far from it. While the methane controversy captured attention, the spacecraft's other instruments quietly gathered important information about the Martian atmosphere. One of the most fascinating discoveries involved a gas known as argon-40. Argon-40 is linked to processes occurring deep within a planet's interior. Detecting significant amounts of this gas provided valuable clues about Mars's ancient geological history. The evidence pointed toward a remarkable conclusion. Mars was not always the cold and lifeless desert we see today. Billions of years ago, the planet likely possessed rivers, lakes, and perhaps even vast oceans. It may have had a much thicker atmosphere and a powerful magnetic field capable of shielding the planet from harmful solar radiation. In many ways, ancient Mars may have been far more Earth-like than most people realize. So what happened? The answer lies deep inside the planet itself. Because Mars is much smaller than Earth, it cooled much faster. Over time, its internal engine weakened. Volcanic activity declined, and eventually the magnetic field that once protected the planet began to disappear. Without that invisible shield, Mars became vulnerable to the constant assault of solar wind. Charged particles from the sun gradually stripped away the atmosphere. Water molecules were broken apart. Oceans vanished. Rivers dried up. Over millions of years, a potentially habitable world transformed into the barren landscape we see today. Mangalyaan's observations helped scientists better understand this planetary tragedy. Its cameras captured vast canyons, dried river channels, and ancient surface features that serve as reminders of a world that once looked dramatically different. Then, after years of exceeding all expectations, Mangalyaan faced its final challenge. In April 2022, Mars entered a prolonged eclipse. For hours, the spacecraft remained in darkness without enough sunlight to recharge its systems. Engineers hoped it would wake up once sunlight returned. It never did. Communication was lost, and India's historic Mars orbiter fell silent forever. Mangalyaan did not discover alien life. It did not reveal living microbes hidden beneath the Martian soil. But it achieved something that many experts once believed was impossible. A nation whose space program began with bicycles and borrowed buildings successfully reached another planet, operated there for years, and helped humanity better understand one of the greatest mysteries in our solar system. And perhaps the mission's most chilling lesson is this: Mars is not just a distant world, it is a warning, a reminder that the line between a living planet and a dead one may be far thinner than we imagine.